Okay, can you hear me? Can you hear me? I don't know how much of that you got, guys. But the thing that I was telling you is that we're gonna play this Kahoot, and you're gonna have this opportunity to earn or to gain some points, as the kind of very similar to the dynamic that we had yesterday in our class. The top 5 are gonna be able to earn these points. Okay, so this is your chance to make it. Okay, and okay, I hope that you're ready. I'm gonna be presenting here the information so you can join this Kahoot. Okay, as I was telling you before, this is a Kahoot that we have played before, but the interesting thing now is going to be this, that you are going to be able to win some points at the end. Okay, so the code is being displayed here, guys. I hope that you can see it, and also you can access here Victoria, the first one. She's very decided, I guess, to earn some of those points. If you didn't have the opportunity yesterday, guys, or if you had the question, or you had the opportunity to answer the question, but your answer was not good, now you have this opportunity to redeem yourself, okay, and gain also those points. And because of this Kahoot, as I told you before, we have played before. Um, you are going to have kind of more chances to win those points. Okay, so be very, very careful. You know that you need to be both quick and accurate. Okay, so that is going to be the key for winning this and every other Kahoot that you play. It's important to be very, very quick and also choose the correct option or the correct answer. Okay, I have Victoria, Michelle, Katia, Carlos, Anna, Lauro, Daniela, and Juni. Very, very good, guys. I'm going to try to check if I can see your comments here. Okay, so the only students that are going to be able to win these points are the ones that participate, obviously, right? So the less participants I have here, or the more are your chances of winning these points. So, okay, you're watching the code already there. Very good. Yes, I was having a little trouble at the beginning, guys. I'm sorry about that. But anyway, are you ready to start with these guys? It's going to be a very, very close competition. Try not to be only an spectator and join to this session, guys, so you can win some of these points, okay? I think that we should start with only these participants: Victoria, Michelle, Karia, Carlos, Ana, Lauro, Daniela, and Juni. Are you sure you don't want to participate for winning those points, guys? Okay, I'm about to start already. Let's go to it, guys. This is something you have seen before. You know this very, very well. So try to be as quick and accurate as you possibly can, okay? So for the first one, anybody got the correct answer here? It is false, okay? Try to, I don't know, to understand very well the answer, guys, so you can not precipitate, okay? So you can choose the correct answer here. So no points for anybody. Now this, you need this to calculate the speed. As easy as it can get. Distance and time. We have one correct answer here. Very good. Let's see who is that. Daniela, starting here the race for the points. Very good. The next one is going to be a car travels 10 kilometers in 1 hour. What is its speed? Going to be 10 kilometers an hour. Very good. You know already about that. So next one. Let's see the points here. Daniela, Katia, and Anna have already those points. Very good. The units of speed are kilograms per second square. Is that true or false? It is false, right? You know that they are meters per second only. Very good. Hey, Anna, joining to this um, podium of winners of those points. Very good. Now, these are all units of speed, except which ones? Guys, these are units of acceleration, meters per second square or meters per second. Okay, so I think that the rest were correct. Only these ones are are not the units of speed, right? No, Victoria, very good. Ascending there. Daniela in the first place. It's going to be hard to take that place from her. A vector has both what and what? Magnitude and direction. Very good. I hope that you're having the enough time, guys, to give your answers because of the lag between the session and the YouTube transmission. I think that it is reduced considerably. So um, one more reason to be quick. A change in speed or in direction is both called. That is acceleration, right? We're talking about acceleration. Very good, Katia. So, Anna, be careful. An object at rest is not accelerating. Is that true or false? It is true, right? If it's not experiencing any movement at all, it is not accelerating. Very good. Not changing the positions. Very good. True or false? An object at a constant speed is not accelerating. What is acceleration? A change in velocity or direction, right? So it is true. If the velocity or the speed is constant, we don't have acceleration. Very good, Michelle. Getting in the position for the points. Very good. An object at a constant speed that is turning to the left is not accelerating. True or false? I just gave you the definition before. And it is false, right? Because acceleration is also a change in direction. Remember that it's a vector and the factor of the direction is important. Very good, Victoria. A negative value of acceleration indicates that velocity is decreasing, velocity is constant, velocity is increasing, or velocity is equal to zero. Negative value of acceleration indicates that what's happening with the velocity? You have negative acceleration. It is decreasing, right? Correct. Not changing positions, very good. To calculate acceleration, you need You need final and initial velocities divided by the time, right? The difference between these velocities divided by the time. So the blue one is the correct. Let's see who got it right. Carlos, very good. Now Michelle has fallen from the points. Carlos, very good. This graph of speed is showing that there's no movement, speed is changing, speed is constant, something is accelerating. The speed is constant, right? Remember that is when you have a straight line is indicated that something is constant. Anna, very good. A push or a pull. What is other way to represent that or to say that? What other word to define a push or a pull? We're talking about a force, right? Very good, guys. Very good. You're. It's very fierce this battle. No one wants to cede their positions. The unit used to measure force. How you call that? You call that? Had very short time for that. It's a Newton. Only one person got that right. Let's see who that was. Awesome, Anna. So yes, the two main types of force. You remember in a homework you did this? What are the two main types of forces? Contact forces and field forces, right? Or forces at a distance. These ones are field forces. Very good. Here, I think it's going to be very difficult to reach Anna. It's up to you guys. Maybe you can give the surprise. These are all examples of actions at a distance force, except pushing an object, right? You need that physical contact to exert that force. Hey, Michelle is back in the points. Very good. Okay, so be very, very careful, guys. Gravity is a contact force. Is that true or is that false? We just saw examples of that, the two types of forces. It is false, right? Right? Because the sun is not touching the earth or the rest of the planets, and they are held in their places or in their orbits by their influence. So action at a distance force. Carlos, they are fighting very, very, very hard for that position. The resultant force will make the car move to the right. Is that true or false? Check the vectors there representing the forces. You're going to move to the right. It is true, right? Because the force towards the right is bigger. So you are going to have a resultant force to the right that is going to cause that displacement. Ah, a surprise now. It is not Carlos nor Michelle. It is Laura Torres this time. These four persons, Anna, Katia, Victoria, and Daniela, they don't want to give up their positions. So it's going to be hard. For every action, there is an equal and opposite reaction. Come on, guys. Which Newton's law is that? Is Newton's third law of motion, right? Okay, now Michelle is back in the points. Very good. Actually, the most interesting part is around here, the fourth, fifth, and sixth places, I guess. This is where the battle is developing. But anyway, congratulations. So with all of this, it's going to be difficult to reach Anna here. But anyway, don't give up, guys. You can do it. An object's tendency to maintain its rest or motion state. What law is that? It's Newton's first law of motion called inertia, right? You remember about that. Okay, no changes in the positions here. Very good. Force equals mass times acceleration. Which one is the law that relates these three terms, force, mass, and acceleration? You remember? It's Newton's second law of motion. No changes here. Renewable source of energy. An example of that, what could be? The wind, very good. Any change in the positions? No. You're fighting fiercely for those points. What describes energy, guys? Read very carefully before you answer. What describes energy? Which answer is the best here? All these concepts are correct. Energy can be transferred. Energy is the capacity of doing work, and energy is also expressed in joules. So congratulations, these two students. Katia and Victoria, very good. Are trying to reach for Anna. Let's see if you can snatch that first place. Which one is about energy, guys? This is kind of a tricky question. If you don't remember the units, none of the others is correct, right? Because newtons is to measure force, watts is to measure power, kilometers per hour is the unit of speed, right? So energy, remember that are the joules. So very good, Anna, Daniela, and Michelle. What about this? Mechanical energy is the sum of kinetic and potential energy. Is that true or false? Mechanical energy is the sum of kinetic and potential energy. That is correct, right? We saw different simulations and diagrams about that. Okay, we have a change in positions here finally. Victoria goes to the second place. Katia, that is not a secure position anyway. What kind of transformation occurs to the energy of the white cat? Potential to kinetic. Unfortunately, no one chose this option correctly. Remember that potential energy is that change in the position. If you transform that, if you change that position, the resultant change is going to be the movement. So it is potential to kinetic energy, right? We'll change here. Okay, we are almost getting to the end, guys. Power equals to, remember the formula to calculate power? Remember your exam? Power equals work divided by time. Only two persons got that correctly. It was Anna and Victoria, the ones that are leading here the points. The unit to measure power is? Power is measured in watts. Okay, joule is energy or work, guys. Watts, okay? So, to answer this correctly, Lauro is again in the position. So Michelle and Carlos were left behind here. We are at the end almost of this exercise. I think that these positions are secure, but I'm not very sure about this one. So Lauro, you have to be very careful in this next, the last question. Also Michelle, Carlos, and everyone else that is close to that position. So let's go for it. Remember about this? Suri and Marcelo ate one pizza each, but Marcelo did it in half the time of Suri's. So who was more powerful? Remember that power is certain amount of work done in certain amount of time. The less time it takes also is going to be the more powerful. So yes, very good. Marcelo was the more powerful, because he needed less time to do that same work. Okay, so let's check the positions here, guys. The third place is going to be for Katia. The second place for Victoria. Congratulations. And the first place is going to be for Anna, right? She maintained this first position. But the most interesting thing is Daniela and Lauro, okay? So these five persons are going to have also this participation following these kind of dynamics that we were reviewing yesterday in our class, okay? So I think it was great, guys. I'm trying to watch here different comments. Okay, I'm sorry about those that are having problems with their connection. I understand. Okay, maybe the image is not perfect, or maybe you couldn't log in. But anyway, I hope that this activity has served for this review, guys. Remember that all the things that we are reviewing, that we are seeing in our classes, are based on some other things that we have been building upon, right? So all of these concepts of power, of acceleration, of force, um, are things that we are going to continue discussing. Maybe not directly, but we need that proper understanding of those previous things to actually understand what we are seeing right now. If you recall, we are watching or we are dealing with electricity and magnetism. So we are going to watch about electric force, electric fields, also power, how we can translate power in this context of electricity and magnetism. That is something that we are going to check later. And okay, that's why I thought this review was important. Oh, and also, you're going to have this opportunity to earn these points as you did, right? Victoria, Anna, Katia, and the other two. I don't remember who those were, but I have a recording of this, so your points are secure. So anyway, guys, I hope that you liked this activity, and it was very very exciting for me, especially that fight between the fifth, sixth positions. It was really really interesting. And that's it. That is going to be it for today, guys. I don't have any other thing to say, but goodbye. I hope that you have liked and enjoyed this session, guys. And I'll see you tomorrow in class, okay?